Welcome to another video on my Arduino Yun with electronics and some fischertechnik motors. Actually they are the XS extra small motors. That is what I think that XS is standing for. Last time I was doing some tests on pulse width modulation. And I found out that this LED was burning, but this motor connected to the same circuit is not running, and that it may be due to a lack of voltage. So what I want to do is start with testing some things. Doing so with SSH again. So let's give it some input. One motor immediately starts to work and one motor doesn't. Now this LED is not burning very brightly. It's actually flashing, and this motor isn't doing a thing. And I am turning the pot meter, and in the past it would do something with the light as well, but it doesn't. So that's remarkable as well. Why isn't that connection there anymore? Apparently. Let me also check the wiring. And I think that is very much necessary. But let's check once again. Alright. Is it doing anything at all? That's a very good question. So here seems to be a problem with the wiring, because right now turning this this spot meter has no influence on this LED, while it usually has. So let me carefully take out this wire, improvised wire, straighten it and put it right back in, and then give it again some input, and now it shouldn't do anything, but it has no influence at all, which is not nice. So what did I do anyway? Well, last time I also, let me keep giving it input. Last time I also disabled this part and enabled this part. It's all pulse width modulation, just done in a slightly different way. But I'm still checking whether these wires are having some frequency input or output. Oops, I shouldn't do that. Alright, I have to be here. Now let's check if this potmeter has some influence. Yes, no doubt about that one. Yes, it has. How about this one? It doesn't even jolt. And now it stops flashing, and now it does. And I still don't get it. Anyway, with all this first testing, it is time to check on voltage on this orange wire and this port, and check further on the pulse width modulation, because that is what it is about now. So in order to see why this motor is not running, and I'm not talking about not running because of lack of input, and yes, this LED burns, and once again, if I turn up the potmeter at the right side, it once again doesn't respond really to my expectations, despite checking these wires, I mean this wire. Anyway, to check upon it, I should actually check some wiring, which brings me to the board, and more specifically the orange wire, this one, and then measure something on the potmeter, on the multimeter. So let's make sure that there is quite some input. Then measure right here, and on full scale of 30 volts, it shows some 2 volts. That is, as long as there is some signal. So it gives 2 volts. Is that enough? Well, if I check on this particular line for the running motor, it says about 3 volts, and this is still 2 volts. So is 2 volts enough? I doubt it. We're out of input again. But then again as well, if I check here, it says 2 point something, almost 3 volts. Do I check it on the other end of the circuit? Same thing. It says 4 volts. And I give some input again. It says 4 volts. And this is where the motor should get its input from. Alright. Well, actually a transistor is a current amplifier, not so much as a voltage amplifier, but it says 4 volts, which should be more than enough to have this motor running. So I'm doing this pulse width modulation. So let's take the multimeter that is capable of frequencies. And while once again there is plenty of input, let's change our view to this motor and multimeter. And this is also the reason why I prefer for video the analog multimeter, but it simply doesn't have frequency. So now I am measuring here, and it says some 200 hertz down to 150 hertz, and here 2 kilohertz. But this is what I like to see. So actually with voltage etc. that should run. And now for completeness, let me also measure the frequency on this part. Let's give some more input, and right here I am measuring 3 kilo ohms, and here I am measuring also 4 kilo ohms. So things are different, and it could be that it is different because of what I did earlier here. But let's once again check on this motor, and it doesn't do a thing. Let's also measure here on the motor for a moment. Yeah, that's 5 volts. Oh, I don't have a potential difference. Oh, that's interesting. That is clearly interesting. Let's move the multimeter, the analog one, and right here to run you must have a potential difference. Well, this shows 4 volts, almost 5, and this as well. So because of that I doubt that it will run. Okay, now I probably ran out of output, so once again with input, this is almost 5, this is also almost 5. Measuring the other motor, so this one with input, this shows 4 or 5, and this shows less. And this is the green one. So there is some difference. There is some clear difference. The potential difference on this motor is different than this one. I have to investigate on that. Okay, so what may be a solution? What could be a solution? And apart from the fact that this LED immediately starts working, which does mean that the transistor is working, but how is it working? So I'm going to replace the transistor for a moment and see how that works out. And to do that I best should stop okay, so now this one is stopped as well, and this gives me the opportunity to carefully replace transistor, hopefully with a similar one, and this should be a similar one, and see how this works out. And this immediately has this effect. So now I'm going to give some input, and now both work. So now I am with input from the console, and I'm turning the pot meter, the right one, right side more precisely, and let's measure for completeness the voltage over. So this is almost 5 volts, and this has dropped down to 2 volts. So this transistor was the culprit. So what next? If I turn it completely down, is there any way that this can be managed? So let me press the switch, and I'm afraid that has no influence, so also because of this I have to keep the input going. Turn the pot meter up, there it goes. Now press the switch, so why doesn't this switch do its job? Well, it does slow down. When I press the switch, it really does slow down, but why doesn't the other one? So let me keep pressing it, turn the other pot meter down, right. So now I have turned the other pot meter up completely, by the way. That one is stopped. And I hear from the noise that the right side motor is slowing down if I turn it to the left, the pot meter, and increases in speed when I turn it to the right. But that is just audible. I don't even see it. So let me turn it up again, and then it works. Remains the question, what influence does pulse width modulation have? I don't know. So anyway, some electronics solved, but the big question remains. Alright. I have been looking for pulse width modulation, as you know, and I found out that the Arduino Yun, as I'm using it, is on pulse width modulation and pins similar to the Arduino Leonardo. And looking at that, there's a lot more information than for the Yun. And then I come to this post, which says analog write is a function to use to set frequency. I know, but if I look to my own code, this is how I set timer and frequency. Here they just say, alright, analog write, etc. Pin 3 runs at 128, you get 980 Hertz, which on my multimeter would indicate decimal 89, decimal 98, sorry. So since I still haven't found what I'm looking for in the case of this, I am inclined to comment out all this and use analog write and then such a thing like that. What would be the implication? I have honestly no idea. So which is which? Let me just say I'm going to write analog 3, which is, by the way, the right side motor. So let me just do that. Copy. Then I go here and let me show you the rest. So here I say copy. This is pin 3. This is what I'm going to comment out, and I better make that nice quick way. And then see whatever happens. I'm very curious about it. Would this indeed mean 980 Hertz? Yes, I have to upload. Alright, time to log in here again. Alright, now what is the difference? Let me just measure this frequency. It says decimal, 1.0, which is very close to 980, but not exactly the same. Let me measure at, oh wait, by all means. Yeah, and now I am measuring decimal around 700. So what am I measuring right here? That is decimal 50, so 500 hertz. Can I wait, I have to make sure that I generate characters, and that says still decimal 500, so 500 hertz. But what I also see is that the running of this motor is not at a constant rate. Alright, well, this just goes on. And when I press the switch, it certainly influences the left side motor, but not the right side. So, is this a good way to do it or not? If I change this to example 64, what would be the influence? To be honest, I have no idea. So that is my last test. What will be that influence? Alright, so in the last part of this video I am going to change this to 64. Upload. Everything stops. And I'm waiting for the signal to be ready, if there's any. Yeah. Then I have to log in again. It starts, but to what frequency does it start? Measuring, it says 1.2. Now that motor does not start. What frequency does this show? 30 Hertz. But if I do it like now, it suddenly starts. I measure again. It says 500 Hertz. Measuring on this side again. It says 70 Hertz. Now 700 Hertz. And this one I have to measure the right spot, 500 Hertz. So that is a difference. It's lower. Is that what I like? I don't know. this way I can do whatever I like. Is this of any influence? Probably yes. But I also noticed that whenever input Q is empty, that the motors and especially this motor is going full speed, no longer controlled. So one other test, giving input, and it slows down remarkably, so it has influence. And this one is not even in the it is not connected to pin 6 to pin 3. This is connected to pin 3, 4, 5, 6, and I didn't, and as you can read here, I don't have pin 6, so likely that something else is still going on. Anyway, that is it for now. Thanks for watching. What did I do? Replace the transistor, this one, and finally found a way to control pulse modulation on the Arduino Yun. Now for some fine-tuning. If you like this video, please subscribe to my channel. Also follow me on Twitter and Instagram, and please donate to keep my blog, website and video going. On my website also how you can donate, and my other projects, and this is to be continued, obviously. So no, not that one, this one. Bye bye.